story bucket.
Alright, well, I'm Kerry, and my project originally was called the Beard Bud Picture Core, crossed out to be Shop Spinner. There were some technical difficulties, so we've modified the project a little bit. So I'll talk a little bit about that today. So my problem is my jokes are really bad, so I don't really have a good way to impress my friends. So normally the only person who laughs is like me for anywhere between 1 minute to 2 days at my jokes. No one else really thinks they're good. So I wanted a way to entertain people, and on the off chance that I get to hang out with the 2 friends I have in grad school, that they would be mildly entertained by this. So what's the solution? So there's 2 ways to impress my friends. They're science or beer. Or if you're in the geosciences, you go with science and beer. So that was the initial motivation for this project. So my proposed plan, so the device that I wanted to develop was going to have 3 main components. It was going to be some sort of rotating tray that you would have glasses on or some sort of container to fill. The platform would rotate, and there would be a sensor that would detect when there was a cup present underneath the spout. And I'll talk about how I could and would do that. And then about to control the flow of liquid into that cup. So as you can see today, that's not exactly what I have, but I'll talk you through kind of what I did and how we ended up where we are right now. So the design process, I started off by making a state diagram. So how is this device going to work, and from that development parts list. So what would I need to complete all those different steps. Then I got to the assembly stage, started putting some stuff together. That's when I started running into a lot of issues. So I had to rework my plan a little bit, kind of revise some of the things we were gonna do. And then what I have for you today is the final first prototype. So this is kind of small for you guys, but this is what my state diagram looked like. So at the top here, we're gonna start by initializing by pushing a button. So you can see over there, I have a green button on the board. That would bring us into our initialization state. And this is where we would store our initial parameters. Specifically, the way I wanted to identify when the cups were in place has to do with magnets that were going to be placed on the cups. So we want to know what's the initial value that the magnetic sensor is reading in. As well as we want to make sure that the valve that would be dispensing liquid is closed so that nothing's coming out. We're not pouring liquid all over our electronics. It's not a good idea. So after the initialization stage, we go into the rotation state. So basically, I have a stepper motor that's it steps. So after every step, it checks the read-in, or it would check the read-in on the, it's called a Hall effect sensor. And if it recognizes a change in the magnetic field, in our case, I had some magnets here. So the idea would be, you put the magnet on the cup, and then once the magnet is close enough to the sensor that it's in place, it would trigger us to go into the fill state. If the sensor wasn't triggered, we would then go back into the rotation state and continue our next step. If we rotated an entire revolution without there being any triggers, then it would go to the shutdown state. So if there were no cups on the entire thing, it would shut down. So then when we go to the fill state, what we do is we actually check to make sure how many cups had previously been filled. So there would be like a maximum number of fills that you could have at any time, because there's no other way for the system to know if the cup that would be under it is already filled. So the idea would be, if we can fit 6 cups on there, that after 6 fills, it would also go to the shutdown state. If it was less than 6 fills, it would then open the valve to let the liquid flow. So that was my original idea. So the first thing I started with was the rotating platform. The main lesson I learned from that is if you buy a cheap thing on Amazon, it probably is going to function like a cheap thing from Amazon. So the rotating platform there is actually Lazy Susan, so you should be able to keep it down on a flat surface and just rotate it. It has bearings on the bottom, but they don't work very well. So it's actually very hard to rotate the platform. Initially, what I wanted to do is have the stepper motor on the side and use some sort of gear system to turn the platform. But in the end, I had to end up mounting it below it, which isn't ideal because it's relatively unstable. So I'm unable to put large or heavy objects on it because it just falls over. So underneath that, I actually just have a series of wooden rods and some zip ties that sort of hold the motor in place. So the next thing was getting the motor to operate. So in addition to my Arduino board, I bought an easy driver for specifically to use with this stepper motor, which I got from SparkFun. So This is kind of the schematic. You can check it out. They have it online with a little setup guide to help you along. So we have a maximum power source of about 12 volts. I think we run around 10 or 11 on there. The first time I set it up, I had some difficulty. I think some of my soldering connections weren't great because I wasn't getting enough current into the stepper motor. So I think it requires between 150 and 750 milliamps, and I was well below that, so the motor wasn't turning at all. So I rewired some of those connections, and then after that I was able to connect everything up and get the motor to spin. So the next part was the Hall effect sensors. So the Hall effect sensor is actually here because I wasn't able to get the dispenser working. I just have it here to show you kind of how that works and how I set it up. So it has 3 inputs here. The first one is just going to be your voltage input. So we have 5 volts coming in, the middle is our ground. We have a 10K resistor between the 5 volts and the digital output pin. And then, so basically what I'm reading in is this digital output. So if you have, so if you put the magnet close to it, it will basically change between a state of 0 and 1 if you have a positive or negative magnetic field. And the other thing that's important to note is that this is a latch sensor. So by that it means once it senses a particular magnetic field, it stays in that state. So once you put like a positive field by it, it will stay positive until you put a negative field by it. And because of that, we would have to alternate the magnets on the cups so that we get a change of state as we pass them by if we were going to implement it this way. So this is dispensing valve. So I bought something on Amazon also, and the description of it wasn't super great, and I don't really know that much about these valves. So when I got it and tried to set it up, it really wasn't capable of doing what I wanted it to do. Essentially, I wanted to be able to give it some input to tell the valve to open or close, but I wasn't able to do that, and it required additional parts that I had not purchased and would not be able to get in time. So because of that, I kind of had to modify the design of the project. So what was it going to do? So ultimately, I wanted something kind of, to entertain people. To, you can put food or drink on it. So I went with instead was now the shot spinner. So in this case, you unfortunately have to fill your own cups up. In this case, I have M&Ms in there. You can put liquids in there. I don't recommend filling the cups up all the way because it can get dangerous. We've also been suggested you can use this for snack moderation. You have to put healthy snacks in half the cups, and then kind of limit yourself. So the idea is that you start off by pushing the button. When you push the button, we go into so this is another kind of state machine that I developed, and this is what I coded, and this is what the project will actually do. It goes into a random number state, so we generate 2 random numbers. The first one is the random number dir, which is the random number direction. So if the number is between 0 and 50, it will rotate clockwise. If the number is between 51 and 100, it will rotate counterclockwise. Second random number is between 1 and 2000, and that tells you how many steps it actually takes. So each of the steps on the motor is just a very small fraction of a full rotation. So basically we generate these 2 numbers, so the platform will randomly spin forwards or backwards some number of turns. As you know, random number generators aren't actually random at all. So in order to not get the same exact sequence every single time, there's a random seed thing that you can do. So basically, it reads in a value of one of the analog pins that I don't have anything connected to, and it uses that to decide when in the random sequence of numbers you'll start. So theoretically, it's sort of random where we start each time, so it's not going to be just the same thing. So the next thing is, so once we've decided what our random number direction is, so like I said, if we're less than 50, we step forward. If we're greater than 50, we step backwards, and then it resets. So then we'll go back to the waiting on the button stage. And then so if you push the button again, you can play again. Oops, that's not what I meant to do. And so feature work. So if I really want to make this project better, I'd really have to invest in getting a much better platform. So most of the ones I found online were either like very heavy or very large and bulky or expensive. This project was supposed to be relatively inexpensive. So I think it might actually just be easiest to kind of like custom design one for what you need of cheaper materials, but of the size, and that would be appropriate for this. Also to get a valve that actually works to get the dispenser working, that would be really cool. Even it could be added back to the setup that we have here. And also with the existing one, you could kind of set up multiple types of games to play. So there's different things that you can do. But yeah, so I will, I guess, thank you, and I will show you what this does, hopefully.
Awesome.
Do you want to push the button?
I'd love to.
Right? Do you want to? Yeah. So if it turns counterclockwise,
Yeah.
it'll say that. Oh, you got a little one. This is a little
Oh,
one.
that was, but it's also.
Yes. It'll tell you to push it again every time.
It always keeps telling you to play again.
Party.
Yeah, so they'll say party if it turns clockwise, and shots if it turns this way. So,
Awesome.
you guys are welcome to come eat M&Ms.
Do they have peanuts in them? Do they have peanuts in them?
They do not have peanuts in them for all of our allergy
That's okay.
friends. The other thing I can show you is I do have the hall sensor hooked up over here.
Yeah, I'm getting an M&M. My purchase.
So this isn't being implemented in this setup, obviously, right now, but in theory, if we were gonna go back to having the dispenser, so I just basically set up the hall sensor here to turn on and off this LED, just to show you that it, which drop it on the floor, didn't do anything.
Kick save.
Shout out to John, he got me this Arduino board for Christmas 2 years ago.
What? Because that's I got to the pie. Oh, yeah. It's a good gift.
So I think right now it's not reading anything, and then, yeah. So one side of the magnet will turn it on, the other side will turn it off.
Cool.
So in theory, implementing this into this system would be each one of those cups would have an alternating magnet, so as it passes, it would change the state. In the code, we would recognize that we've changed the state, and then we would know to fill the next cup.
Pretty cool.
That's all I got.
Questions?
You can have M&Ms too.
Exactly, I don't know what else, wants to know.